All right, today we're going to be talking about paragraph proofs, but before we do that, we're going to go ahead and go through a couple practice problems about angle bisectors. So, if ray AM bisects angle FAD, find the measure of angle RQS. So, first off, I know that these two angles are congruent because they're being bisected, and I'm trying to find the measure of angle RQS down here. So, RQS is equal to 3x. That's our goal. Now, if I know that these two angles are the same because they're being bisected, that means I can set them equal to each other. Y is equal to x plus 15. Now down here, is there anything that I can assume from this diagram? Well, yeah. I know that we have a straight line, which means that we do have a straight angle occurring. So therefore, I can say 2y plus 3x equals how many degrees in a straight angle? 180. So, from here, we're going to go back to Algebra 1. Now, I have two different equations, the blue and the red, and they both have two different variables in them. Both of them have a y and an x. So, what we need to do is we need to go ahead and solve one of these by substitution or by elimination. We get to choose. So, what I see here is that one of the equations is set equal to y. So, I'm going to take what y is equal to. Y is equal to x plus 15, that whole chunk, and I'm going to replace the y in my second equation with it. So I now have 2 times x plus 15 plus 3x equals 180. Equals 180. Now from here, I only have x's now. There's no more y's by substitution. So I can go ahead and just solve for x. So I now have 2x plus 15 plus 3x equals 180. So give me 5x equals 165. And then if I divide both sides by 5, we end up with x is equal to, let's see, that'll give me 33. So x is equal to 33. Let me double check that. I got x equals 30 over here. What did I do wrong? Oh, I see what I did wrong. I did not distribute fully. This should be a 30 right here. 2 times x is 2x. 2 times 15 is 30. So that is my mistake. It should be a 30, which would make this 150, which would make this 30. So x is equal to 30. This is wrong. So, and again, I divided this by 5. Let's just get rid of that fully. So at this point, we now know that x is equal to 30. From here, I need to go ahead and find out what the measure of angle RQS is. And to do that, I'm going to take this 30 and I'm going to plug it in for x. So I now have the measure of angle RQS. That's kind of hard to see, isn't it? Let's switch it. The measure of angle RQS is equal to 3 times 30. 3 times 30, which will give us 90 degrees. Now you may be thinking, this doesn't look like 90 degrees, and I completely agree with you. It does not look like 90 degrees. However, we cannot just trust what a diagram looks like. We need to trust our numbers. And our numbers say that this angle is 90 degrees, so we're going to go ahead and stick with that. So therefore, angle RQS is equal to 90. All right, so today we are going to be covering paragraph proofs. Our learning target is I can write paragraph proofs about segments and angles. We'll also be learning a little bit about disproving proofs as well. So we're going to see some proofs that we can disprove down the road too. So keep that in mind as we're going through today's lesson. We will be talking about disproving things as well. So let's get started. So first off, I'm just going to walk you through our first paragraph proof. Now, they look very similar to our two-column proofs because they give us something that's given and they tell us what we need to prove. And oftentimes they'll give us some diagrams as well. So, our proof goes as this. Given angle O is 67.5 degrees, so I can mark that 67.5 degree, and angle P is 67 degrees and 30 minutes, we want to prove that angle O is congruent to angle P. So we want to prove that both these angles are the same. Now, the way that this worked, it went, since there are 60 minutes in 1 degree, so they started off with our conversion rate. Their goal is to make sure that these numbers are the same. So if one of them has minutes and one of them doesn't, we need to either convert them both to minutes or convert both of them to only degrees. So I'm going to go ahead and convert everything just to degrees. So since there's 60 minutes in 1 degree, that means that 67 degrees in 30 minutes is equal to 67 and 1/2 degree. Because again, this will give me 30 minutes divided by 60 minutes, which gives me 1/2. So that's where that 1/2 comes from. So since angle O and angle P now have the same measure, they are congruent. And this proof is now finished. And that's literally all there is to a paragraph proof. We're just writing out what's happening in these proofs. So keep that in mind. All right, so problem number 2. Given the diagram as shown, we want to prove angle DBC is congruent to angle E. So let's go ahead and get started on this. According to the diagram, can I assume anything? Well, yes. Angle ABC is a straight angle. So according to the diagram, angle ABC is a straight angle. Therefore, now I'm using this upside down 3 dots. All this symbol means is therefore. So you're going to see a lot of shorthand as you get into proofs. I want to make sure that you guys are familiar with the shorthand. Will you need it in this class? Not necessarily. Will you see it in the future? If you choose to take a math career, definitely. Especially once you get into college mathematics courses, you're going to see that symbol a lot. So, since ABC is a straight angle, we can assume that we can use the angle addition postulate here. So I can say 2x plus x equals 180 degrees by angle addition postulate. So therefore we can say 3x is equal to 180 and x is equal to 60. So we know x is equal to 60. Now, since we already know, since angle E is equal to 60 degrees and angle DBC is equal to 60 degrees by substitution, maybe like, what are we substituting? Well, I'm substituting 60 back in for x. So that's where the substitution's coming from. Plugging 60 back in for x. So since angle E is equal to 60 and angle DBC is equal to 60, by substitution, the two angles have the same measure. The two angles have the same measure. Therefore, angle DBC is congruent to angle E. And that is our proof. This is now proven. We are good to go. So, if you'd like, go ahead and pause the video and take a picture or finish writing this down. And I'd like you to compare it to the 2-column proof. Just look at what's the same and what's different. See which one you kind of prefer, see which one you'd more likely want to do down the road as well. But this is our first paragraph proof that we completed on our own. So, here is the 2-column proof of it. Now, again, very similar to it. Diagram is shown as given. ABC is a straight angle. We have our equation and our solving here, simplifying and all that. And then also at the end, very similar as well. So, as we can see, they're very similar. The paragraph proof is more like reading a book. This is more structured, like reading directions. So it's entirely dependent on which one you prefer more. However, once you get into the higher math courses, it will only be paragraph proofs. 2-column proofs will disappear entirely, and you'll need to do everything in paragraph form. So keep that in mind. All right, here is our second proof. So problem number 3, given angle 1 is acute and given angle 2 is acute, we want to prove angle 1 is congruent to angle 2. So let's think about this. What does acute mean? Well, acute just means less than 90, right? Less than 90 degrees. So I know that both of these angles are less than 90. So can I actually prove that they're congruent though, just based upon what information they give me? Well, no. So I'm going to go ahead and start with this conclusion cannot be proven. This conclusion cannot be proven, not with the information that they give us, not just knowing that these two angles are acute. We need more information. Now, if I say that it cannot be proven, I can't just say it, I need to still prove it. So we need to provide a counterexample to this. So I'm going to go ahead and give angle 1 and angle 2, I'm going to give them both measurements. So, for example, if angle 1 is equal to 60 degrees and angle 2 is equal to 23 degrees, these are just random numbers I came up with. They can be any numbers that are acute, so anything less than 90, greater than 0. So if these two angles, angle 1 is 60 and angle 2 is 23, are these two angles both acute? Well, yes. So for example, if angle 1 is equal to 60 and angle 2 is equal to 23, both angles are acute. Both angles are acute, but angle 1 is not equal to, or is not congruent to, angle 2. Now, what is in red here? What is in red? This is our counterexample. So I can't just say that something cannot be proven true. I need to provide a counterexample anytime that occurs. So that is our counterexample. Now, counterexamples will only occur when we're proving that proofs cannot be true. When it cannot be proven, we provide a counterexample. If it can be proven, it's going to be just like the proof that we just did in problem 2. Now, you may be wondering, how would this look in a 2-column proof? Well, very similar, in fact. And before I move on, just want to signify that this proof is done. So let's go ahead and compare this to a 2-column proof. And feel free to pause the video if you need to finish. So here's our 2-column proof for it. Same type of thing. Angle 1 is acute and angle 2 is acute. That's given. And then the conclusion cannot be proven. There's not enough information to prove or disprove this conclusion in this specific problem. And of course, I can provide a counterexample below, but in 2-column proofs, it's not necessarily needed. However, it makes a lot more sense logically if you provide one, and that backs up your reasoning as well. That provides more evidence to make sure that your proof or your counterproof is true. All right, here is problem number 4, our next proof. Go ahead and pause the video if you'd like. Try this one out on your own. All right, so given angle D is equal to 90 degrees, that's given to me, and angle E is obtuse, meaning that it is greater than 90 degrees, but less than 180. We need to prove angle D is congruent to angle E. Now, can this be proven? Well, no. So I'll go ahead and start with this conclusion. This conclusion cannot be proven. So, the reason that this cannot be proven, well, first off, we know angle E is obtuse. So I'm going to go ahead and say that. Since angle E is obtuse, what does that mean about angle E? Well, it must be greater than 90. Its measure is greater than 90. On top of that, green should work. Since angle D is equal to 90 degrees and angle E is greater than 90 degrees, the two angles have different measurements. Two angles have different measurements. Well, if that's the case, if two angles have different measurements, are they congruent? No. So therefore, angle D cannot be congruent to angle, I don't like that angle, to angle E. And that is our proof. Now, anything after the blue, all of this, anything after the blue here, that is all of our counterexample once again. So that is our counterexample. All right. Now, again, here is the proof one more time in two-column style. So very similar, given information, they're not equal to each other because one is 90, one is larger. And then, there needs to be a slash through here saying that they're not congruent. So angle D is not congruent to angle E because they are not the same measurement, therefore they are not congruent. So again, very similar. Get used to paragraph proofs, but we'll be using lots of two-column proofs in this class. So make sure that you're familiar with both and you'll be good to go. All right, here's our final proof of the day. In problems 10 and 11, write paragraph proofs. So I'm just going to give you guys problem 10. What they give us the diagram as shown, and they tell us that AC bisects angle BAD and AE bisects angle DAF. What we need to do is prove that angle CAE is a right angle. So if you guys would like, go ahead and take a minute, pause the video if you'd like, and try this one out on your own. All right, so according to the diagram, what do we know? Well, I see a straight angle, so I can say angle BAF is a straight angle. That's the first thing that I can see. From there, I can say ray AC bisects angle BAD, so angle BAC is congruent to angle CAD. So I know that both these angles right here are congruent. Now, I don't know what their measurement is, so I'm just going to give it an unknown number, but I know that they're the same because it's being bisected, so they're congruent. So they both get the same variable, they both get x, and x is just our unknown number which we'd like to solve. Now, I can do the same thing with ray AE, so let's do that. So I'm going to say, and ray AE bisects angle DAF, so angle DAE is congruent to angle EAF. Same reasoning. So these two angles are also congruent. Now, different congruency though. It's not going to be x again, so I'm going to give it a different variable. I'm going to call them both y this time. So both of these get a y. Now, again, we're trying to prove angle CAE is a right angle here. So that's our main goal. So from this point, I can say x plus y equals, well, what's all these angles equal to? X, y, and y? Well, they equal that straight angle, 180 degrees. So therefore, I can say 2x plus 2y equals 180 from combining like terms. Then let's simplify this. If I divide both sides by 2, the 2's will cancel out over there, and I'm left with x plus y. Then 180 divided by 2 will give me 90 degrees. Now again, we're looking for angle CAE, this green angle over here. We want to prove that's a right angle. So looking at angle CAE, we see that angle CAE is equal to x plus y. So you can go ahead and add that in my proof. Angle CAE is equal to x plus y. So by substitution, angle CAE is equal to 90 degrees. So again, we see x plus y equals 90. And if I look at CAE, it's angle x and angle y combined. So if I substitute x and y, x plus y equals 90, if I substitute that in for angle CAE, I get angle CAE is 90 degrees. Therefore, I'm not done yet. I just know it's 90 degrees, but I'm trying to prove it's a right angle. Therefore, angle CAE is a right angle because right angles have a measure of 90 degrees. And we are now finished with this proof. We have now proven that angle CAE is indeed 90 degrees. All right. Here is the two-column proof of it. Again, very similar. Pause the video if you'd like to take a second and compare and contrast to the paragraph proof that we just wrote. All right. So that is it for today's learning target. Our learning target again was I can write paragraph proofs about segments and angles. So we have now finished that up. If you guys have any questions, please leave comments. Get a hold of me if you'd like. Other than that, thank you guys for watching. I'll see you later.